Hey everyone, today we are going to solve the Daily LeetCode challenge of 4th April 2024 and the problem statement is maximum nesting depth of the parenthesis. So let us first understand the problem statement. According to the problem statement, we have been given a string S which is a VPS. Now what does a VPS means? A VPS means that it's a valid parenthesis string, okay? Now what does a valid parenthesis string means? It means that for every opening bracket, there will always exist a closing bracket. And similarly, for every closing bracket, there will be an opening bracket. So let's say if I have a string like this, then I'll ask you that, is this a VPS? That is this a valid parenthesis string? So you'll say yes. Why? Because we can see that for this opening bracket, we have this closing bracket. Similarly, for this closing bracket, there is an opening bracket. Correct? Now, if I'll ask you, is this a valid parenthesis string? You'll say yes. Why? This we can see for this opening bracket, this is the closing bracket. Similarly, for this opening bracket, this is the closing bracket. And for this opening bracket, this is the closing bracket, right? So this is a valid parenthesis string. Now I'll ask you, is this a valid parenthesis string? So you say no. Why? Because for this opening bracket, we have a closing bracket. But for this opening bracket, there is no closing bracket, right? We should have a closing bracket for this to be a valid parenthesis string. But there is no closing bracket. Similarly, if I'll ask you, is this a VPS? So you'll say no. Why? Because for this closing bracket, there is no opening bracket. Correct. And for this opening bracket, there is no closing bracket, right? So this is not a VPS, correct? So now we have understood that what is a valid parenthesis string. Okay, so it has been mentioned that this S is always a VPS. Okay, that is for every opening bracket, there will be a closing bracket, and for every closing bracket, there will always be an opening bracket. Correct? Now this S contains parenthesis, that is opening and closing brackets, integer and operators as well. Correct? And what we have to do is we have to find out maximum nesting depth of the parenthesis. Okay. Before that, let us understood what does a nesting parenthesis means. Okay. So if we have something like this, so we can see that this is a parenthesis, correct? And inside this parenthesis, we have another parenthesis. So whenever we will have something like inside a parenthesis, another parenthesis is present, then it is called nesting, correct? So we can also have like this. So we can see that this is a parenthesis, inside it there exists another parenthesis, and inside it there exists another parenthesis. So it's called nesting. Okay, that is inside a parenthesis there exists another parenthesis. Okay, so that's a nesting parenthesis. Now what does it mean by nesting depth? So it has been mentioned in the problem statement that if we have an empty string, then its depth is considered to be 0. Okay, so this is the depth and this is a valid parenthesis string. Okay, so if we have an empty string, then its depth would be 0. Okay, and if we have a single parenthesis, that is an opening bracket and a closing bracket, then its depth is considered to be 1. Now, if we have something like this, then what would be the depth? So we know that the depth of this one, that is the parenthesis present inside it, would be 1. Correct? Why? Because we know that the depth for a pair of parentheses is 1, right? So the depth for this one would be 1. And what would be the depth for this one? The depth for this one would be 1 plus this depth, right? The depth of the parenthesis which is present inside it. So what would be the total depth? The total depth would be 2, correct? Similarly, if we have something like this, right? Then what would be the total depth? We know that the depth of a pair of parentheses is 1, correct? So what would be the depth of this one? The depth of this one would be 1 plus this one, correct? And what would be the depth of this one? The depth of this one would be 1 plus this entire, that is 1 plus 1. So what it would be? It would be 3. Right. And we can also consider it in this way that if we have a valid parenthesis string like this, then we can see that how many pairs of parentheses do we have in this nesting parenthesis. We have 1, 2, 3. And what is the depth? The depth is also 3. So we can consider it in this way as well. That is the total number of pair of parentheses that we will have in a nesting parenthesis would give us the depth of the parenthesis, because we can see that in this we have a total of 3 parentheses, and that 3 is only the depth of this nesting parenthesis, correct? So now that we have understood this, so let's see how we can solve this. Now, what is the depth of this valid parenthesis string? It's 1, correct? Because we have only one pair of parentheses, correct? What is the depth of this parenthesis string? It's 2. Why? Because we have a 2 pair of valid parenthesis string, correct? Now, what is the depth for this one? The depth would be 1 plus 1 plus 1, that is 3. And we can also see that we have a total of 3 pairs of valid parenthesis string, correct? Now for this one, what would be the depth? The depth would be 1 plus 1 will give us 2, 3, 4, correct? And we can see that we have 4 pairs of valid parenthesis string, and the depth for this one is only 1, correct? So what would be the maximum depth in this case? It would be 4, because for this one we have 4 and for this one we have only 1. So the max of 4 and 1 will give us 4, because we are interested in finding the maximum depth, correct? Now, can we find the pattern over here? The answer is yes. Now, tell me that for this valid parenthesis string, what is the count of opening bracket? So, the count of opening bracket is 1. So, let me write it over here. Opening bracket is 1, correct? Now, for this valid parenthesis string, what is the count of the opening bracket? It's 1 plus 1. That is 2. So, opening bracket, let me represent it as OB. Opening bracket's count is 2. Correct? Now for this valid parenthesis string, what is the count of the opening bracket? It's 1, 2, 3. So in this case, we have opening brackets as 3. Correct? Now for this one, what is the count of the opening bracket? It's 1, 2, 3, 4. Correct? So opening bracket count is 4. Now you can't say it's 5 by considering this, right? Why? Because this is a nesting parenthesis. This is not a nesting parenthesis. This is a separate one, right? Because we can see that this is forming a nesting parenthesis, because inside this pair we have this one, correct? And inside this one we have this one, and inside this one we have this one, correct? This is not inside any of these, right? That's why we won't consider it while calculating the depth for this one, right? The depth for this and this one would be calculated separately, correct? So we notice that the count of the opening bracket and depth is same, correct? Now let's see that how we can use this in order to solve this problem. So we understood that whatever the count of the opening bracket would be, it will give us the depth of that nesting parenthesis, correct? Now, this particular string S contains parenthesis, operator, and operands as well. But are we interested in this operand and operator? The answer is no, we are not interested in this operator and operands. We are only interested in the parenthesis, right? And specifically, we are interested in finding out the count of the opening parenthesis, correct? So what we will do is, we will iterate over the string S, and whenever we'll find an operator or an operand, what we'll do is we'll simply ignore it, correct? Now let's see how we can solve this. So we discussed that we are only interested in finding out the count of the opening bracket, correct? So what we will do is, we will take a variable answer, which would be initially 0. So this answer will be storing our final result, correct? And we will take another variable, let's call it as open bracket, okay? So it would be initially 0 as well. And what this open bracket will do is, it will keep track of the total number of opening brackets in the current nesting parenthesis, correct? So what we will do is, whenever we'll find an open bracket, correct? What we will do, we will increment the count of open bracket plus plus, correct? And whenever we'll find a closing bracket, what we will do, we will decrement this open bracket count. Why? Because this is not an open bracket, right? So we will decrement the count of the open bracket. Fine. Now let us quickly do a dry run in order to understand this in a better way, okay? And additionally, at each step, what we will do, at each step, we will set answer as the max of answer, comma, open bracket, correct? Why are we using this open bracket? Because we are interested in finding out the count of open bracket only, correct? So initially we would be here, correct? Our answer is 0. The count of open bracket would also be 0 initially, correct? Now initially we are here, and this is an opening bracket. So since this is an opening bracket, what we will do, we will increment the count of the opening bracket, so it would be 1. And now what we will do, now we will set answer as the max of 0, 1. So what will be the max of 0 and 1? The max would be 1, so this will get updated to 1, indicating that we have got an opening bracket, correct? Now we'll move forward. Now this is an operand, and we are not interested in operand. So what we'll do, we'll simply ignore it and we'll move forward. Now we have got a closing bracket, correct? So what does it mean? It means that since we have got a closing bracket, we will decrement the count of the opening bracket, so it would become 0, correct? And now what we will do, we will set answer as the max of 1 and 0. So answer will remain 1 only, correct? Now we'll move forward. Now we have encountered an operator, and we are not interested in an operator, correct? So what we'll do, we'll simply ignore it and we'll move forward. And by that time, what we'll do, we'll again find the max of answer and open bracket. That is, we'll find the max of 1 and 0. So answer will remain as 1 only, correct? Now, since we have encountered an opening bracket, what we will do is, we will increment the count of the open bracket, so it would become 1, correct? And now what we will do, we'll find the max of 1 and 1, so it's 1, so answer will remain as 1 only, correct? Now we'll move forward. Now, again we have encountered an opening bracket, so we will set this to 2, that is, we will increment the count of the opening bracket from 1 to 2, correct? And now what we will do, we'll find the max of 1 and 2. So what would be the max of 1 and 2? It would be 2. So answer will get updated to 2, indicating that we have encountered 2 opening brackets and these are the 2 opening brackets. Correct? Now what we will do? We will move our pointer forward. So we have encountered an operand. So we are not interested in an operand. So what we'll do? We'll simply move forward. We have got an operator. We are not interested in an operator. We'll move forward. We have got an operand. We are not interested in it. We will move forward. Now, we have encountered a closing bracket. So what we will do, we'll decrement the count of this opening bracket. So it would become 1. Now, what is the max of 2 and 1? It's 2 only, so answer will remain as it is. Now, we'll move this pointer forward. Now, we have again encountered a closing bracket. So what we'll do, we'll decrement this count, so it would become 0. Now, what is the max of 2 and 0? The max is 2 only, so it will remain as it is. Now, we'll move forward. Correct? Now, what does this 0 indicate? This 0 indicated that we successfully found out the count of opening bracket for this particular part, right? Because when we started to find out the count for this particular part, what was the value of open bracket? It was initially 0. Then when we encountered this one, it became 1. When we encountered this one, it became 2. So this 2 indicated that in this particular part, we had the maximum count of opening bracket as 2. And we can see that as well, that we are having only 2 opening brackets over here, correct? Then what does this indicate? This indicates that we got a closing bracket over here. That's why it got decremented by 1. And again, it got decremented by 1 to become 0, indicating that we have got one more closing bracket, correct? So for this particular part, we found out the total count of opening bracket as 2, correct? Now, where we were? We were over here. So we found an operator. So what we will do? We are not interested in it. We will ignore it. Now we found an opening bracket. What we'll do? We will implement the count of opening bracket to 1, correct? Now we'll find out the max of 2 and 1. So the max of 2 and 1 is 2 only. So answer will remain as it is. Now we'll move forward. Now we have again found out an opening bracket. So what we will do? We'll increment its count. So it will become 2. Now what does it indicate? It indicates that till now we have found out 2 opening bracket, right? For this particular part. Correct? Now we'll move this pointer forward. Now we have again encountered an opening bracket. So what we'll do? We will increment this count. So it will become 3. Correct? Now, what does it mean? It means that in this particular part, we have encountered 3 opening brackets. Correct? Now, we'll find out the max of 2 and 3. So, what would be their max? Their max would be 3. So, answer will get updated to 3, indicating that we have found out 3 opening brackets. Correct? Now, we'll move forward. Now, we have encountered an operand. Since we are not interested in it, we will move forward. Now, we have encountered a closing bracket. So, what we'll do? We'll decrement this. So, this will become 2. Now, we'll find out the max of 3 and 2. It would be 3 only. So, answer will remain as it is. Now we'll move forward. Now again, we have encountered an closing bracket. So what we'll do? We'll decrement the count of opening bracket to 1. Now we'll find the max of 3 and 1. So it will remain as 3 only. Correct? Now we'll move forward. Now again, we have encountered a closing bracket. So what does it mean? It means that we have to decrement this count. So this will become 0. Now we'll find the max of 3 and 0. So the max would be 3 only and it will remain as it is. Now we'll move forward. Now we can see that we have processed all the elements of this S, and what we have got as answer, we have got 3 as the answer. And what does this 3 indicate? This 3 indicates that there are total of 3 opening bracket in a nested parenthesis. Correct? So what does this mean? It means that we have something like this, right? Then only we will have 3 opening bracket in a nested parenthesis. And where it is over here. We can see that we have 3 opening brackets in this particular nested parenthesis. Correct? And the depth would be 3, and we will return this 3, correct? Now, I hope it is clear to you all. So, let's quickly code this. So, we will start on by creating answer, which would be initially 0, and it will keep track of what is the maximum nesting depth of the parenthesis, right? So, we will be storing the result in this variable. We'll take another variable, open brackets, which would be initially 0. And what it would do, it will help us to keep track of the total number of open brackets that we have, correct? Now, what we will do, we will iterate over the string S. So, we will say current is to S. Now, if this current is an opening bracket, then what we will do? If it is an opening bracket, we will increment the count of open brackets, correct? Else, if this current is a closing bracket, then in that case, what we will do? In that case, we will decrement the count of this open brackets. Correct? That is, we will say open brackets minus minus, right? And what we were doing at each step, we were finding out the max of answer and open brackets. Now, what we will do over here, we'll finally return answer. Now, let us quickly run this. So, it's giving us the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if we consider n as the size of the given string s, then the total time complexity would be order of n. Because what are we doing over here? Over here, we are iterating over all the elements of this string s, correct? So what does it mean? It means that we will be processing all the n elements. So therefore, the time complexity would be order of n, correct? And what is the space complexity? The space complexity is order of 1 because we are not using any extra space from our end, correct? So that's all about today's daily LeetCode challenge. Thank you.